Good morning, all of you. This is Dr. Nageswara, Assistant Professor of Physics, SRR and Xavier Government Degree College, Autonomous Vijayawada. So today we will discuss about Indian rockets and development after Indian independence. Because we know the science and technology is the part of any competitive examinations. For example, in our state for APPSC Group 1 examinations, the syllabus comprises technology in space and defense, in which we know the major development activity is under ISRO, that is Indian Space Research Organization. What is its functions, what it will done, and their main functions are development of rockets and development of satellites. And the second topic of this science and technology is science and technology. Of course, in which we will discuss about what is the relation of science and day-to-day life incidents. Maybe it belongs to the biological sciences, maybe it belongs to the physical sciences, maybe it belongs to the chemical sciences. We will discuss in this concept. And the third concept is information and communication technology, that is SCT. We know this ICT is inculcate with all the government schemes promoting using of ICT and different governing programs also and services. And fourth point is energy requirement efficiency and efficiency. We know all nowadays the energy is must. Without energy or without power we cannot survive. Ancient days we used that is conventional energy sources. Maybe that is petrol, diesel, maybe natural gas, maybe wood, etc. But we know those are all conventional sources which are decreasing its quantity when we are using. So that after some time those conventional energy resources may not be available. So that we want to develop some energy sources, that is called renewable energy resources. Here renewable energy resources is nothing but it may be solar energy, it may be wind energy, it may be hydel energy, it may be nuclear energy, etc. Of course, this is one of the concepts in the our competitive examinations. And last one is environmental sciences. We know the pollution is increasing day by day. All the industrial countries like America, England, Russia, France, Japan, Germany, China, they are increasing the pollutants in the society. So that what happens, due to the increasing these pollutants, the temperature of the earth increases. So uneven happen in the society of world. So this is the syllabus comprising the competitive examinations of our group 1 examinations or whatever it is competitive examinations. Today we will discuss about science and technology which is related to Indian space program. We know in 1957 USSR first launched his first rocket, that is Sputnik 1. At that our Prime Minister Jawaharlal Nehru decided to start one of the research program on space and technology. At that time one of the famous scientists, that is Vikram Sarabhai, on his head we started the National Committee on Space Research in COSPAR. Of course, later in 1969 it is changed as ISRO, Indian Space Research Organization. So that we are saying that father of Indian space program is Vikram Sarabhai. Under his head we developed from very small range to now we are sending so many rockets or so many satellites into the space. And actually after 6 years of Sputnik 1 launching, that is in 1963, we sent the first rocket into the space, that is called sounding rocket. Sounding rocket is very small rocket. There is no applications, there is no satellite we are sending into the space by using this sounding rocket, but is only test rocket. Actually that is happening at the Tumba, that is near to the Thiruvananthapuram. It is a fishing village. Why the scientists selected this Tumba for the launching of these Indian rockets? Because Tumba is a place which is going near to the that is Earth magnetic meridian line which is passing through the Tumba. So it is a good place to send the rockets into the space. Of course, so that we are using that Tumba, which is in the there is a diagram which is related to the sounding rocket. First round is rocket which is sent by our Indian remote sensing agency. Of course, thereafter, second application of our ISRO is to develop the satellites. Actually, the ISRO has taken two parts. One is rocket development and second one is satellites development. We know rocket is used to send satellites into the space. Satellites are used for the applications. That means that by using rockets, the satellites can be sent into the space which is revolve around the Earth in separate orbits. The applications of these satellites is it may be used for communication purpose. It is nothing but live programs of live telecast of many TV programs, and to take photographs of the Earth by using the Earth orbit. So these are the applications of the satellites. The first satellite, that is Aryabhatta, which is sent in 1975 by using our best friend, that is USSR, in 1975 by using Intercosmos. So that is about the satellites. Now our program starts with the satellite launching vehicle. Because the main function of the ISRO is to develop the rockets to send the satellites into the space. Actually, there is two orbits we are using to send the rockets into the space. One is lower Earth orbit, that is LEO. And second one is GSO, that is a geostationary orbit. So these two orbits, geostationary orbits, will be used for communication purpose. Low Earth orbit, that is low Earth orbit, will be used to take photographs and to take the geographical area of the Earth. So that there is two applications we may use for this purpose. So SLV is a very small rocket to send satellites into the lower Earth orbit. That is, lower Earth orbit is around 400 km from the Earth's surface. At that place, the satellites revolve around the Earth in this case. So that is the first, SLV is the first program by our satellite organization agency for remote sensing and meteorology. And the first experimental flight, that is called SLV-3, that is Satellite Launching Vehicle 3, which is in August 1979, was the only partially successful. Of course, the failures are a stepping stone to the success. In that case, immediately our scientists designed one more satellite, that is SLV. In 1980 July, they launched, that is by the Rohini satellite, is perfectly successful. So the Rohini satellite, which helped us to get some photographs of the Earth. Thereafter, one more launch of SLV is held in 1981 and one more launch is in April 1983. So that there is 4 launching vehicles we observed by using the satellite launching vehicle. So what is the importance of these satellite launching vehicles? The satellite launching vehicle only send a satellite whose weight is only 40 kg. It's nothing but only small satellites can be sent into the lower Earth orbit by using the rocket, that is SLV. Of course, at the 400 kilometers of height orbit. And what is this SLV-3? Actually, it is 4-stage rocket. What is this 4 stage? Actually, any rocket whose weight increases is nothing but whose number of fuel is need to very high level fuel is required. When the weight of the rocket decreases, the fuel is also very small is enough. In such cases, we are using, there is 4 steps rocket. This is actually SLV-3 rocket, which is in 1993 sent from Shore, that is a Sriharikota range, that is our Nellore district. So what is these 4 steps? The first step is ignited on the Earth surface. Then what happens? It is take off, lift off from the Earth. When the first says there is some liquid, that is some solid fuel is there. When the solid fuel is completed, the first part is detached from the rocket. Then the second stage will be ignited. Then what happens? After gaining some height, that may be one more 100 kilometer or maybe 50 kilometer, the second stage is also detached from the rocket when its fuel is completed. Then the third stage is ignited. After completing these 4 stages, the last, there is a satellite is placed. That satellite will be released into the orbit, that is lower Earth orbit around 400 km from the Earth surface. So this is about the history of the rocket technology. Of course, rocket technology not new to us, because in our rural area also, in the Deepavali, there is a crackers will be prepared by our rural people without knowing the scientific knowledge. So that is also, it is nothing but that is the genes, that rocket technology is behind our genes from ancient days also. You know, Tara Jubalu, that is the principle behind the rocket technology. In Tara Jubalu, we use only small fuel. That may be we are using phosphorus, because phosphorus is a burning material. Of course, immediately it will burn, so that we are adding some coal. So to slow down the burning process. Similarly, here we will use, there is some fuel to burning this rocket. There is 4 stages we have. It is having 17-ton weight of this rocket. It is height is 22 meter. So this is about the SLV. This is 4-stage rocket. All fuel are solid fuel only, so that whose weight is very, very high. Of course, this is SLV is successfully launched in 1980. So thereafter, our India is the 7th country throughout the world who successfully completed its launching, after USSR and the United States of America, France, United Kingdom, China and Japan. So now we are the 7th country successfully completed launching of rockets into the space. So, and next one is SLV, you know, a satellite launching well whose capacity is only to send 40 kg satellite. Now we want to improve that one. For that case, we designed one more satellite launching vehicle, that is called ASLV. That is Augmented Satellite Launching Vehicle. What is this ASLV? Actually, by using this ASLV, we can send a satellite of up to 150 kg into the lower Earth orbit. So that the capacity of the satellite, the payload of the satellite, we are increasing by using this ASLV. Of course, the first augmented satellite launching vehicle whose payload is 150 kg, which is kept in the lower Earth orbit around 400 kilometer. We know he is one of our famous scientists, Abdul Kalam. When he is actually one of the famous student of that is Satish Dhawan, one of our great scientists, he is successfully taken in front of our world by our rocket technology. So we know that is this technology, that is ASLV, whose weight is 40 ton and height is 24 meter, and it can upload, that is satellite up to 150 kg in that is circular orbit of 400 kilometer, that is lower Earth orbit. So what is this different steps of the ASLV? We know in SLV what we said, SLV is a 4 stages solid fuel rocket. In this ASLV also 4 stages solid fuel rocket. But the difference is the weight of the satellite ASLV is more than the SLV, so that we are sending 3 times more than the weight or payload of the satellite than the satellite launching vehicle. Because SLV you can send only up to 40 kg per rocket. By using this ASLV, we can send 150 kg of rocket. Of course, in 1988, first in 1987 and 1988 and in 1992, we sent 3 rockets by ASLV. Of course, in 1992, we sent SRAS-C, that is whose weight is 106 kg of rocket in the orbit of 255 km into 430 km. It is nothing but it is not a circular orbit. It is 430 kilometer radius, not a radius actually, that is in elliptical orbit. At a position, the rocket distance is 430 kilometer from the Earth's surface, and at a position, the distance is 255 kilometer only. When it is 255 kilometer, is nothing but very near to the Earth. At that time, when we have taken photographs, it is more clear than the 430 kilometer. And of course, already told that this is 4-stage developmental rocket. It is and in 1994 we sent one more satellite, that is SRAS-C2, by his weight also 106 kgs. This satellite comprises gamma ray burst experiment and a retarding potential analyzer, and it worked for 7 years. So that is the greatness of our ISRO to send this rocket. Of course, this ASLV whose payload is only 150 kg, but it is not sufficient nowadays because we have more technology, more applications is required. Once upon a time, only they are used for photographs only. But now we are using telecommunications, our communication system is developed. Phones, a number of phones we are using by using cell phones. So that the capacity of these satellites is increases. In such cases, we want to increase the payload. One more satellite we launch, that is called PSLV. PSLV is nothing but Polar Satellite Launching Vehicle. It is successfully launched in 1993. This PSLV is called workhorse of ISRO because so many successful events were conducted by ISRO by using this Polar Satellite Launching Vehicle. What are those applications? Not only sending satellites, there is a number of applications. We know Chandrayaan-1. Chandrayaan-1 successfully completed by Indian scientists because of PSLV, where Chandrayaan team that is well sent to the moon is because of PSLV rocket. Not only that, we know that is nowadays we are using Agni missile in defense. Prithvi missile. We know Agni missile can send up to 5,000 kilometers. That is, can send up to 5,000 kilometers by changing this PSLV. By small modifications of PSLV, that PSLV is converted into the Agni missile. And also for Prithvi missile, it can send up to 500 kilometers with more payload. There is nothing but the bomb size may be increased. So of course, these defense achievements by using this ISRO will be discussed in the next class or next presentation. So this is about the PSLV, that is a diagram of the PSLV when it is before the launching. It contains actually 6 boosters and it has capability of 1600 kg. We know that is the ASLV capacity is only 150 kg, but the PSLV capacity is 1600 kg payload. It can send into the sun synchronous orbit around 620 kilometers. Of course, when whose weighting decreases up to 1050 kg, this satellite can send into the geosynchronous transfer orbit. What is this geosynchronous transfer orbit? Actually, these satellites, that is also called geostationary satellites, it is at the height of 36,000 kilometers. At the orbit of 36,000 kilometers, the satellite which revolve around the earth, it takes 24 hours for one rotation. We know in case of earth also for self rotation it takes 24 hours. So both are 24 hours, so that when we are observing the rocket from the earth surface, it looks like stationary. It looks like stationary. So that this orbit is called geosynchronous or geostationary transfer orbit. Of course, what is its position? PSLV has national requirements as well as international customers also it is received. What is this? We know by using this PSLV, we send more than 100 satellites at a time by using this PSLV rocket. That is the greatness of our ISRO. And over the years, continuous technology improvements one by one based, we know very first there is only sounding rocket, there is no satellite we send. There is a SLV that is 40 kg only, that is ASLV 150 kg only, PSLV that is 1600 kgs. There are further improvements that PSLV is developed up to 1750 payload also, in the range of 620 kilometers sun synchronized polar orbit. What is this structure? Actually, this PSLV has 44 meters of height and its weight is 295 ton. We know 295 ton is nothing but morely we are using fuel. This very small weight belongs to the structure. So it contains also 4 stages. These actually in SLV there is only liquid solid stages. In ASLV also 4 stages are solid stages. But in this case, PSLV is 4 stages, alternate solid fuel and as well as liquid fuel will be used. What is the importance of this liquid fuel? We know solid fuel is very less efficient than the liquid fuel. But even our IOs also we are observing. When we are observing that is coal or wood, more quantity is required to cook food. But when you are using natural gas, the very small quantity is enough. Because when it is in gaseous state or liquid state, whose efficiency is very, very high. So that in the rocket technology also we are using not only solid fuel, liquid fuel also we use. Because when we are using liquid fuel, the quantity of the fuel may be decreased, the efficiency will be increased. So that is beauty of the PSLV rocket, in which of course whose weight is 139 ton of solid propellant, which is usually augmented by 90 ton to 11 ton 6 solid propellants already in the diagram is seen. The second stage is liquid propellant, because the first stage we use solid fuel and the second stage we will use liquid fuel. It contains we use Vikas engine for the uplifting the rocket. The third stage is also a solid fuel and the fourth stage again we will use liquid fuel. So this is about different steps of the PSLV rocket construction. And one more development by our ISRO is GSLV. That is a geostationary satellite launching vehicle, because when days are day by day increasing, the applications or requirements are increasing. Now you want to see live telecast of cricket, maybe IPL matches, maybe international cricket matches, maybe football matches. Maybe when political meeting is going on, our Prime Minister or maybe Chief Minister is any meeting, we are seeing directly live from our house. Because of these satellites, that is there are those satellites which is kept at the geostationary satellite orbit, that is also called geosynchronous transfer orbit. So those satellites will be used for communication purpose, maybe or for our cell phones also. For that satellites, when we are sending into the geosynchronous transfer orbit, one more rocket is required, that is called GSLV. That is a geosynchronous satellite launching vehicle. Of course, whose capacity increases up to payload of 2 ton, that is a 2000 kg. So you mean that by using this GSLV, we can satellite up to 2000 kg into the geosynchronous transfer orbit. What is its construction? When see, that is about the GSLV construction of a rocket. That is when at the time of launching at ISRO, that is a SHAR, Sriharikota range. Actually, it is a 3 stages only. In these 3 stages, we are using with 460 ton of liquid, or maybe that is fuel, and whose height is 49 meter. The first stage is a solid booster. Second stage we use in the liquid engine, liquid propellant, and third stage is also we will use liquid fuel. But the importance of this GSLV third stage is we will use cryogenic engine. In this cryogenic engine, we will use liquid, low temperature liquids as fuel, that is called liquid hydrogen. Because liquid hydrogen at a very low temperature is a good fuel whose efficiency is very, very high when compared with the remaining fuels. But hydrogen is required for the burning purpose, so that liquid hydrogen is also used as oxidizer for this propulsion of rocket in the third stage. Here also, of course, the first stage is detached after exhausting the fuel, and then second stage is ignited. And after second stage fuel is completed, third stage is ignited. And finally, the rocket, that is the top of the rocket, which is sent into the required orbit, that is GSTO. And thereafter, one more requirement is increasing. So that thereafter, our ISRO scientists developed one more satellite launching vehicle, that is called GSLV Mk3, whose capacity payload is 4 ton, that is 4000 kg rocket also we can send into the geostationary satellite launching vehicle, that is orbit, geosynchronous transfer orbit, up to 4000 kg, that is 4 ton. So this is called Bahubali rocket. Beautifully, our Indian scientist named as Bahubali rocket because of our movie we know Bahubali. So its capacity is 4 ton. Actually, this GSLV Mk3 before launching at our shore. You see here there is 2 boosters we are observing, and one more there is in between there is 2 steps are there. So this is also a 3-stage vehicle. In this 3-stage vehicle, there is 2 boosters we have whose total weight is 630 ton and height is 42.4 meter. Actually, these 2 boosters each having 200 ton. These are the 2 boosters. Initially, those 2 boosters will be ignited initially. When it is going through some height, the first step will be closed, that is detached, and the second stage is ignited. Of course, all these 3 stages are using liquid fuels. After 3 stages completed, the final stage, there is a satellite which is sent into the geosynchronous stationary orbit, that is nearly 36,000 kilometers height from the Earth's surface. These satellites have so many applications. So that we are using these rockets. This is the development of Indian rockets of our ISRO. But this is only one side of ISRO. The second side of ISRO is to develop the satellites. You know, satellites is the application. Rocket is which is a vehicle to send these satellites into the orbits. So what are the development of satellites, our Indian ISRO, that will be discussed in the next presentation. Thank you very much.
ఈ కార్యక్రమం మీకు ఎంతో నచ్చింది కదా? ఇటువంటి మరిన్ని వీడియోల కోసం అనతి కాలంలోనే 20 కోట్ల వ్యూస్ సాధించిన డాక్టర్ సమరం మల్టీ ఛానల్ నెట్వర్క్ సమర్పించు గోరా సైన్స్ వరల్డ్ ఛానల్కు సబ్స్క్రైబ్ చేయండి, లైక్ చేయండి, మీ ఫ్రెండ్స్కి షేర్ చేయండి. అలాగే ప్రక్కనున్న గంట సింబల్ని ప్రెస్ చేయడం మర్చిపోకండి.
Please download SAMARAM Channels app from Google Play Store and watch your favorite channels. Click the bell icon and subscribe to the channels.